Good evening, all of you.
Good evening, Bharti garu.
Good evening, sir.
Tarun, Ramshankar, Monica, Sainath, Vidhi, Imrana, Bhavishri.
Good evening, sir.
Yeah.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening, good evening.
Good evening, sir.
Sharing my screen. I shared my screen. Please confirm it.
Yes, sir, I can see.
Your voice is very low. I'm not getting.
Yeah, we're able to see you.
Or else, 1 minute, I will change the room here. Some fan sound is noise. One. Just to bring the charge. Charge. Yes. Yes. Close that door. Yes, sir. So last document we discussed about in-memory computing and also parallel process versus massive parallel process. What is the difference between parallel process and massive parallel process we have said, right? So these are the key points we have covered. So today we deeply jump into these RDDs. So here Spark data objects. Are called RDDs. So full form of, resilient
Distributed data sets.
distributed data sets. So if you want to define RDD, simply RDD is a logical name. Which is collection of partitions. Which is collection of partitions. These partitions, each partition, runtime, these partitions are loaded into RAM of worker nodes. So these partitions you can say as a data partitions. Runtime. That means when job is submitted. These partitions are loaded into what is the location? RAMs of worker nodes. Of Spark cluster. So this is the key thing here. So about this statement, a simple demonstration. That is a simple explanation with a pic. Treat this as a Spark cluster. Forget about the statements for now. I take RDD1. SC Spark context dot parallelize. Input is a list. List is having the values 10, 20, 30, 40, 50, 60, 70, 80, and 90. Okay, default number of partitions here 2. So if you want to increase, you can increase, and also you can decrease. Later about those statements we will see. Now I have 2 partitions. Partition 1, simply I am saying P1. So how many values are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means maybe some 5 values may be in the first partition. 10, 20, 30, 40, 50. Partition 2.
62.
Which is P2, remaining partition, remaining data. Let's say 60, 70, 80, 90. So runtime, what happens? These partitions are loaded into P1 loaded into first system, P2 loaded into second system. These are okay. Now I am saying RDD1 dots. So this is divided into 2 tasks. This is task 1. This is task 2. These 2 tasks will be executed parallelly. Suppose if sum is applied on the partition 1, what is the result? 60, 150. The sum of first partition is 150. This is the result by first mission. Second mission 130. 130, 80, 210. 210 plus 90, 3.
300.
Maybe these 2 results are collected by other mission. Again here the sum, the final sum.
450.
On that way this will happen. Okay. Thus these two partitions are executed parallelly. in in-memory computing style. Basically, at each system, in-memory computing is super faster. That too, this in-memory computing is executed parallelly. Okay.
Stop.
You can increase this is just a default count. You can increase the partition count and also you can decrease the partition count. Suppose data volume is bigger, increase more number of partitions. Default number of partitions for the Spark RDD, 2.
2.
There are 3 ways to create RDD. Number 1, when you parallelize local data. Local object using Spark context. Okay,
Yes.
this is one way. So in the previous example, we did the same. Second thing is when you perform, okay, this thing I keep as a third point. When you read data from file, when you read data from file using Spark context, that RDD will be created. And third point, third way, when you perform transformation, on existed RDD, a new RDD will be created. Okay. So before going deeply into these 3 steps, one more statement about the RDDs. RDD, what is RDD? You know, RDD is a collection of partitions. Once again, I repeat. It's a collection of data partitions.
Only 2 partitions, sir.
Default.
Default is 2.
If you want to make it 100, you can make it.
Okay.
Depends on your data value. Depends on how many parallel processes that you need.
Okay, sir.
Just hold on the line 1 minute. Come on, sir. This is a collection of data partitions. Now on RDD, we can perform 2 operations. Number 1, transformations. Number 2, actions. Okay, these are the 2 things we can perform on a RDD. Look into the examples of these transformations. This is changing state of data. So not to another RDD. That means, example, map is one transformation. Your RDD dot map. RDD dot flat
Map.
map.
Yes, map minus flat.
Okay. RDD dot reduce by key. RDD dot union with RDD2. Similarly, RDD 1 dot join RDD. In this way, all these are different transformations. Every transformation is changing shape of the data. Okay, from
Yes, sir.
one state to other state. Okay.
So it's like first we are using map, then flat map, then reduce by key, then union, then we are transferring to join.
Yes, it depends on your flow of sequence, what you want.
Okay.
Sometimes I create a new field, sometimes I will drop some of the existed fields. Whatever it may be,
Mhm.
everything I'm doing some transformation.
Okay.
So all these transformations will be executed parallel.
Mhm.
Yeah. So, but whenever I perform a transformation, what happens? One more
When you are detailed.
the new RDD will be created based on our.
Here.
But whenever data flow will be executed,
Mhm.
when you perform action, data flow will be executed from its root RDD. From its root RDD. Example actions.
Root RDD is the main
Main.
RDD what we have created.
Your RDD dot collect. This is one action. And previously you said RDD dot sum. This is also action.
RDD dot count.
Count. Okay. RDD dot save as text file. Suppose I want to dump the results into some data lake or HDFS, then I use save as text file.
Save as text file.
Then path handling. All these are actions. When I perform action, then only the data flow will be executed.
Yes, sir.
So little elaboration for this. What exactly the meaning of that? Try to understand. Forget about statements and syntaxes. X. I'm keeping six values. What is that X?
List.
The list, which is local object, right?
Yes.
So if I say X, sum of X, this is executed by what? executed by
Sum of x.
Python runtime, because X is a local object. Understand? Now I am converting this sc dot parallelize of X. Now what is the tar? Here X is what? List, which is local object. That means the location of this object is my system, my laptop. But whenever I create RDD runtime, the RDD partitions are not in my system. The RDD partitions are in Spark cluster. That too in worker nodes, that too in RAMs. Okay.
Yes, sir.
Now here, what is R1 now?
RDD.
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 Okay. Now next step I am doing R2. R1 dot map. Some transformation I am going to perform. Lambda X. Here X represents each element. Each element of R1. For each element, I want to add 100. This is my transformation. What is the data in the RDD? Same this data. Okay. What about now? What is R2? What is our rule? When I perform a transformation on existed RDD, one more RDD will be created, right?
Yes, sir.
Yeah. Now this is R2 is also RDD. What is the result?
10,
If I run it, what is the result?
110, 120.
120,
110, 120.
130, 140, 150, 160. Got it. Now, I'm saying still R3 equal to R2 dot, I'm applying something, filter, lambda X, X greater than 130. What is R3? Now filter is also a transformation. On existing RDD, if I perform transformation, one more RDD is created.
Yes.
Now R3 is also RDD.
RDD.
Now what will be the data in this?
140.
There's a 140, 150, 160.
160.
Up to 160. Like this. Understand? Now I'm saying that up to now, what is the flow? R1, R2, R3. I am performing some action on R3. R3 dot collect.
Collect.
What is this collect?
Read data.
Is action.
Okay.
So whenever I perform action, the data flow will be executed from root. How it knows? R3 input is what? R3
R2.
140
R2.
and
R2, what is the input?
R1.
For R1, what is the input?
Let's see.
Directly the local object. For
Okay.
this R1 input is not other RDD. For R3 input is other RDD. For R2 input is other RDD. For R1 input is not other RDD. Directly it is taken from the source, which is local object. That's why this is called a root. Root RDD. Now first
R1 is root RDD.
okay. Once R1 is executed, then R2. Then R3. Understand? Then result will be collected into your local machine. In this way, the data flow will be executed. This entire thing is called data flow. Understood? That is the meaning of the previous two lines. Transformation, changing state of data from one RDD to other RDD. So map, filter, flat map, reduce by key, all these are the different transformations. But when I perform a transformation, one more RDD is created. But when I perform action, then only the data flow will be executed. Please ask me.
Can I ask you one thing, sir? R1 equal to SC dot parallelize X. What is SC stands for?
SC, Spark, I said like one statement, Spark context, right?
Yes, sir.
Spark context object is SC.
Okay.
Okay.
Sir,
So
are there any limitations for that object? Like it should be only list or tuple like that?
it can be list or it can be tuple also.
Dictionaries?
No,
Dictionary? No. Only list or tuple.
only list or tuple.
Okay, sir. Also, when you say R3 dot collect, it will redirect to R1 and the output will be the list of R1, sir.
R2 goes to R2, then it goes to
R2 is taking output from that input from R1 output. Okay, then R3. Finally, you are getting what? Finally, when you say R3 dot collect, what is the output? 140, 150, 160. This is the data contained in R3. This entire execution happens internally at Spark cluster. Finally, you are getting this result. Understood?
Okay, sir.
Sir,
Yes, sir.
that means until an action is triggered, the execution won't be started.
Yes. That is what I'm going to say now. This thing is called execution evaluation.
execution evaluation.
Is called lazy. Evaluation. Not evaluation. Evaluation. So what is the meaning of it? Lazy evaluation. When you create RDD or perform transformation on RDD, RDD. Just RDDs are declared. But not loaded into RAMs of cluster. Okay. When action is performed, then only data flow will be triggered. From its which position?
Root RD.
Root RDD. This kind of execution style is called lazy execution. Okay. No. Now come back to recall the previous. Three ways to create RDDs. What is the first way? When you
When you use by
Parallelize local object. Okay, already you have seen. Second way,
Sure.
when you read Dataflow,
When you read Dataflow,
file using Spark context. The object name is SC. Third,
transform,
when we perform
transformation,
transformation on existed object. Let's see example for all the three ways. I'm going to talk about the way one. Parallelize local object. Let's say A equal to only 5 values. Capital A equal to SC dot yeah. Understand. Now here the small a is local. Capital A is RDD. This is way one. Way two. Read data from file. Using
Spark context.
Spark context, which is SC. So in Databricks, when you start Databricks cluster, this SC is readily available to you. But if you are executing from the Google Colab, you have to create a SC object. Okay, in the practical part, I will show you how to create that SC object. Way two. For example, there is a file. File is emp.txt. ID is salary. Think that you have 4 employees. Okay. How many records are here in this data?
Oh,
Okay. Think that in this way, it can be 4 million records or 4 billion records. It doesn't matter. We are working with the distributed file systems. It doesn't matter about the data volume. Okay. So I want to read the data from this file. Let's say emp equal to. First, before this one statement. First, I will use this copy. This is way one. Look at this file. In file equal to. I am saying open and giving the path. Suppose the file is under my content and emp.txt. Now file object is created. After that, data is equal to in file dot read lines. What is this data? Tell me. Data is a list object. This is
List of words.
local object. RDD is not created. Understand? So here one important point. If data volume is 5 terabyte, first you tell me your Python can able to read this data from this 5 TB. You cannot, because of that list object has to stay in RAM. You don't have 5 TB RAM, right?
Yes, sir.
That's why data reading will be failed. Understand? So even though the less volume of data, if you set data equal to in file dot read lines, this data object is a list object, which is a local object. This is not RDD. That means data is not RDD here. Observe here in right side part, emp equal to sc dot text file. I'm giving the same path. Slash emp dot txt. Now emp is RDD. Understand? Data type within that RDD, data type is object type is data type is list. Under list, each element is string. Entire line as a string. Got it. This is way number 2. Let's have a look at third way. With so previously you said emp equal to something. Sc dot text file. Content. Now is RDD. What is the data type? List of
List of
each element.
string.
String. That means entire line as an element. What is the content of it? What is the content of it? First element.
Not one.
Let me take this 101, 20,000, 30,000, 40,000, and 10,000. This is first element. Second element 102. Next 103. That is third element. 104.
20,000.
Understand? Now this is RDD. As per way 3, what is the rule?
Transformation of data
Perform transformation
on executed RDD.
on existed RDD. EMP is already existed. On this, I am going to perform. Words equal to emp dot map. Here lambda represents each element. Lambda x. So lambda expression is automatically performing a loop. At each iteration, value is coming into X. In the first iteration, this is the value. In the second iteration, this is the value, like this. You need not write any for loop. Automatically, looping will happen internally. Lambda X. Each X, I am splitting. Splitting based on what is the delimiter between field to field? Comma. First field, comma, second field. I am separating that. Split I apply. Now, what is the words now here? EMP is existed RDD. On that, I performed a transformation so that words is
RDD.
RDD. Understand? What is the data type? Already that is a list. Under that, each element is again a list. Under that, each element is string. This is the data shape. Come on, check what is the data shape. List. Under that, first element is again list. 101 first element. What is the value? 20,000. Now one more list. 102. 30,000. Next, one more list. 103. 40,000. Next, one more list. 10,000. Now, high level, that is a list. Under that, each element is again a list. Under sublist, each element is a string. Now, is there difference between data transformed from one state to other state or not? Now, words is RDD as per rule 3. Still, I am continuing this. Let's take this step. So this is the data of words RDD. Its content is this one. I want to perform any aggregation. Okay. I want to separate only salary part. Okay. Now, in my hand, words is there. Now I am taking salary. Input words dot map. Lambda X. Here X is what? Each element. Each element is what? Each element is what, sir?
List.
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 Right? List. In that list, what is the salary? Second one. How to take the second one?
Of one.
X of 1. But I want this as integer, right? This is my expression. The given expression will be done for each element. If this expression is applied to the first element, what I will get? First, you tell me what is salary?
20,000.
What is salary? RDD, right?
Yes, sir.
Because I performed a transformation on existed RDD so that one more RDD is created though. So that's why salary is also here, RDD. What is the data type? High level list.
Left.
Each element is
List.
Teacher.
each element is integer. What is the data of it? What is the data of it? From the first element, what I will get?
20,000.
20,000 as a number integer. Second element.
30,000.
30,000.
Next 40. Next 10. This is the data. Right? Now I am saying that salary dot not collect. Instead of going with collect, let's go with sum. Salary dot sum. What is sum? What is sum?
One.
Total.
Sum is
Action.
action. What happens when I perform action? What
Evaluation.
happens when I
You
perform action?
will create one more RD.
From root.
No problem.
Executed from root. How it knows?
Dataflow.
Salary input is what,
Dataflow.
sir? Salary input what? Words. Words input what?
Employee.
Salary input words. Words input what? EMP. EMP input is what? Not other RDD. From a file source, it is taken data. That's why EMP is treated as a root RDD. Okay. Now the flow execution is like this. What is the data flow? When you perform action, this data flow will be executed. The root is EMP. From the EMP to
Words.
words to
Salary.
salary. Then action. What is the action you have given? Sum.
Sum.
The sum is executed. Understand? Like this. So on a existed RDD, if I perform some transformation, one more RDD will be created. So these are the three ways to create RDD. Now we see data flow of RDDs. Execution step. Observe this flow. I'm writing all the things. Let's say R1. First R1. R1 to R2. R2 to R3. R4. R5. Think that the flow is like this. Actually, it seems to be one flow. In fact, this is two different flows. What is the flow one? What is the flow? R1
R1.
to R4. This is one flow. What is another flow?
R1 to R5.
Same thing.
R1 to R5.
R1 to R5.
1 to R5. There are two separate flows. But for R4 input is R3, for R5 input is R. Now I'm going to say something like R5 dot collect. What is collect?
Action.
Action.
Understand? Now for R5, what is the input, sir?
R3.
R5 to R1.
R3, right?
R3.
Okay.
Again for R3, what is the input?
R2.
R2.
R2, what is the input?
R1.
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 R1, what is input? Not any R.
Nothing.
That's why R1 is treated as.
Root RDD.
Box
R2.
contents.
What happens internally in the Spark cluster. Okay. First step. R1 loaded. Enter. This is first step. Then second step. So for R1, what about computation? Computation required or not? Because that is root. Computation not required. Just reading raw data, that's it. It is not performing any computation. Next. Whenever data has been read, if computation not required, then status will be ready. Whenever status is ready, it waits for next RDD in the flow. Here, what is the next RDD? R2. Got it? So after completion of the R1, now R1 status is ready. Status means successful completion. If status is ready, then it is waiting for R. Okay, next step. Second step, observe. Same thing you try. R2. That means R2 partitions. Loaded in RAM. Next step. In R2 computation is required. Let's say computation successfully done. Then status ready. Whenever status ready, previous RDD will be removed. So here previous RDD is what? R1 will be removed. Then waiting for next RDD. What is the next RDD?
R3.
R3.
Now who is there in the RAM? Tell me.
R2.
Who is there in the RAM? Only R2. R1 removed, right? R1 is removed. Next. Come on. R3. Loading. Let's say computation. Successful. During this computation, R3 loaded means it needs input, right? The input it is taking from R2. R2 is taking from
R1.
R1.
Okay, by reading data from R2, the computation will be done. Understand? R3 loaded, computation is done. Then status
That's ready.
Status is ready.
ready. Then R2
Waiting for
Will be
Will be removed.
removed.
R2 will be removed.
then waits for
Next RDD.
next
That's
RDD. What is
fine.
it? What is the next RDD as per the flow?
R4
R4.
or R5.
R5 because you submitted action on
R5. Okay.
R5, right? Like this. Okay. Come to the last step. R5. R5 means R5 partitions, right? Loaded in RAM. It needs input. It needs input. R5 needs input. Where is its input?
R3.
R3.
R3 already there in the RAM or not?
Yes, sir.
Yes, available. So that by reading data from the R3, the computation will be performed. Next status. Ready. Then R3. Rim. Understand? Then what about R5? R5 next RDD is what?
Next is action.
R5. So next RDD is what?
R4.
Action.
No, there is no RDD.
Action.
That is the last because you performed action on.
R5.
R5.
On which RDD you perform the action, that is last RDD. There is no next RDD, right?
Yes, sir.
Then, so no need to wait for next RDD. That's why action will be executed.
Action.
Action will be executed. What is the given action?
Collect.
Collect. That means all the results will be collected into your local machine. Okay, action will be executed. Once action is executed, R5.
Remove.
Remove.
Now who is there in the RAM?
Nothing.
Local object.
Nothing.
Hmm.
Now your Spark clusters RAM is free or not? About this job.
Yes.
Okay, all RDDs are removed. Once action got performed, no RDD will be there into the RAM. So let's try to form a table based on this explanation. Try to form a table. Before this same flow I am taking. 1 minute. What is our previous flow? This is our previous. R1, R2, R3, R4, R5. You said action on R5. R5 dot some action. First work. Load. That means memory allocation in the Spark. After that, computation. Then status. Then wait for. Then remove. Just remember this picture in the mind. Probably 5 steps I have taken. In the beginning for R5, R3 input. For R3, R2. For R3, R2, R1. As a first step, R1 is loaded. Computation not required because it is a root. Status ready.
Ready.
Waiting for
R2.
what will be removed?
Nothing.
Nothing will be removed. Okay, reverse it. Reverse it. The remove status I am keeping in 4th position. One minute. One. Okay. Remove last, we will keep this one. Huh? What is the last? Wait for. Status ready. Remove. What will be removed? Nothing. Wait for.
R2.
R2.
Next step.
तुझ्या बाबांना फोन करायचं बाबांच्या phone वर.
R2 loaded. Next. Computation.
Done.
Let's say successfully completed. Done. Then status. Ready.
Done.
Remove.
R2.
R1.
R2.
R1 will be removed.
R1.
Once R2 status ready, R1 will be removed. Okay. Then wait for.
R3.
R3.
Next step.
R3.
R3 load.
R3.
Computation.
Done.
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 Status ready.
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 R2 removed.
R2.
R5.
R5.
R5. Next.
R5.
One.
Done.
Done. Status ready.
Ready. R3.
R3 will be removed. Wait for.
No way. Action.
Action.
Wait for action, because for the R5 there is no next RDD, right? Now, after action done, action also completed. Then action status ready. Then what will happen?
R5 is removed.
R5 remove.
Then wait for.
Nothing.
Nothing. Now who is there in the RAM finally? No one.
No.
No RDD is available in the RAM because you got our results. Next onwards, we don't need that data into the RAMs. Got it? This is what like a data execution flow.
Sir, where will the result be stored?
Currently, what you said? What is the action?
Correct.
Collect. Collect is collecting data into your local machine.
Local machine. Okay.
Okay. Suppose if you say instead of collect, if you say save as text file, result will be stored into text file. If you say save as Parquet file, data will be stored into Parquet file. It depends on what action that you are performing, right?
Okay, sir. It will be stored into local file.
It depends on like your storage system. Suppose I am configuring this to the local file. That's why data will be stored into local file. Suppose if I configure this to HDFS, data will be stored into Hadoop.
So
If I-
initially we took the local object and we used sc.parallelize or something
It
and
is
changed
list
it
object.
into.
It is list object just to show you. But data is millions of records. Can you keep the millions of records into a list object? No. At
No,
the
sir.
time where the
No.
data will be in a file. Understand? So that
Okay, sir.
more big data, 10 terabyte, 20 terabyte, can you keep the 20 terabyte file in your laptop?
No, sir.
At the time you will keep data lake or HDFS. Understand?
Okay, sir.
Like that. So to which you have configured your Spark, into that it will write the data. You can write into anyone, any file. Even you can write into different clouds also, maybe GCP cloud, AWS cloud. So the related statements you will use it. The file, only the configurations only need to be changed.
Yes, sir. Got it.
So this is simply this thing, but one more important point. Okay, better tomorrow about that point we will discuss about a DAG. Just for my remembrance purpose.
Hello, sir.
Tell me.
Sir, meaning of computation means transformation.
Computation means transformation. Execution of the transformation is called computation.
Oh, sir, in lazy evaluation, you are saying before action there is no any transformation happen. Only the saving is there.
I did not say R1, R2, R3, R5, and then action. Okay?
Yes.
So here computation not required. Here computation required, computation required, computation required, then action. Understand? Like this.
Yes, sir. According to lazy evaluation, you said action needed, then the process will start. The execution of flow will start.
Yeah. Now when I perform action, then only R1 is loaded. Understand? When I perform action, then only R1 loaded. That's why what is our statement in the beginning? When I say R5.collect only, this table is implemented. Not when you write the code, right?
Okay.
So after you say R5.collect, then only this flow is happening. Suppose if I don't perform action, just RDDs are declared, that's it. Not yet executed, not yet loaded into the RAM. Understood?
Yes, sir.
One important point tomorrow we'll touch, just to recall that. DAC. Full form directed acyclic graph. Exactly whatever the flow that you have executed, this entire flow is finally controlled and implemented by this DAG engine. Okay, what exactly is this one? First we will discuss, then the Spark components we will discuss. So this is what like our tomorrow's agenda. Number one, DAG. Second one, we'll be dealing with the Spark components. Once the Spark components completed, then we can start our practical part. Any idea about the Spark components? One is Spark core. Second one is Spark SQL. Third one, Spark ML. Spark Graphics. Spark Streaming. These are the Spark components. Okay, so these two things tomorrow we'll finish. One is DAG, second is Spark components. Then we can start our practical. Okay, see you tomorrow at 7. All of you understood today's concept?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah, thank you.
Thank you, sir.
Thank you, sir.
Yes, sir.
This notes is with you once again. I share it. Just in 2 minutes.